Hi, welcome today to the OpenEDGE Base Specification and Sled Concepts track we're presenting today. I would have much rather done this in person. However, given the circumstances, I think that everybody understands what's going on. Originally, myself, Doug Blevins, and Mike Moore, who is an OpenEDGE product lead for Nokia, and also the co-lead for the OpenEDGE sub-project under the telco project within the OCP, was going to do this together. We prepared the material together. However, given some of the scenarios, we decided to let me present this particular topic by myself. With that said, when we look at what we're going to be talking about today, we're going to be talking about a new base specification that we're working on under the OpenEDGE subcommittee. And we're also going to be talking about some different ideas for some sled concepts and the needs for each of these. We're seeing the edge evolve. We know that things are changing, things are shifting, getting more complex. And at this point in time, we don't know exactly how all the parameters of the edge are going to play out. So the development of this base specification and looking in the future for sled concepts to fit into the OpenEDGE platform is kind of the scenarios where we're looking at and looking for help from some of the vendors as well. So with that said, what is the current OpenEDGE specification? Well, it was a very well-defined solution that was intended to go into some of these edge challenge locations where you may fight with rack space, particularly depth is a real challenge for some of these locations because they've been defined to be able to be placed into really constrained environments. Power to these solutions are also a consideration, how the rack widths are and what those are going to be, because you're going to retrofit these solutions. In addition, NEBS type requirements, how you're going to cool these solutions, where the I/O and the power connectivity come from as well. So when we look at these particular implementations, we have to understand exactly where and how these things are going to be implemented. You can look here at the bottom left-hand picture of the chassis implementation, and this is showing a rendition of the power supply units that's at the lower left corner with the rack management controller integrated into that particular slot. In addition, you could have up to 5 half-width 1RU slots, or if you look to the right-hand side, the current specification defines, for the compute sled, defines in particular 2 types of compute sleds that have been implemented. One is a 1RU sled, which has 2 SSD drives and a PCIe card that's implemented on the solution, as well as some OCP mezzanine for additional networking and standard functionality you would want to see on this type of a slot. And if you look at the bottom, there's a 2RU sled unit, and in this 2RU sled unit, you get 2 additional disk drives, you get 2 additional PCIe slots. So it allows you to have some level of flexibility in the current implementation on determining whether you need more compute, more I/O, or more storage. And you can see the 2RU sled is targeted more towards allowing more I/O and more storage connectivity in these solutions. However, when we looked at these things, is it going to be enough? Is it going to be enough for the edge solutions that's coming along? These edge solutions are getting smarter by the day. They need more capability, more intelligence, more flexibility, and they also need to be able to interoperate and be able to be managed, orchestrated, and detected and discovered, and all those things in a unified fashion. And that's where we kind of looked at, evolving the new implementation to the base specification to understand that how these things might come together and how these things might work. In addition, the new sleds may be required in order to introduce additional applications, and some of these applications are shown below. You may have analytics capabilities that's put in because some of these targets may require advanced learning, machine learning, and artificial intelligence, where these things are self-learning and being able to determine what their next configuration should be. You may need to improve the performance of certain payload types or certain traffic because it's not able to have a low latency path of that particular packet isn't being met by its current connection. So you could have additional storage applications required from CDN type applications. And I'm not only talking about video delivery here, I'm talking about anything that could require low latency. As you know, the evolution of 5G is going to bring about many new applications with its extra speed, bandwidth, and jitter control that's available. And, having large databases, control at a closer location to these particular end users could be really, really beneficial. There's going to be applications that people haven't even thought about, and this is where the flexibility comes in. We're going to need to have that capability to be understood and well defined, and then be able to allow that expansion in a unified fashion that everybody can take advantage of and everybody can evolve over time. And then finally, there's going to be local I/O applications. You may want to have more networking to the particular rack, and when that's done, you may want to have a switch sled. And there's already some work that's being done by particular ODMs and OEMs that are developing switch sleds already. So when we look at this, there's definitely a need to evolve the great start that we've had with the OpenEDGE solution. So what is the base specification? What are we trying to achieve with that? As we look at the base specification, our intent is to define essentially requirements that allow new sleds to be evolved and new sleds to be envisioned, and be able to bring these on board in a fashion that makes them easy to discover, determine what they are, and what their capabilities are. In addition to that, we're also looking at defining the new types of sled types and how these things communicate together. So you may be able to be better served by having different communication types other than Ethernet that allow sled-to-sled communications. And we'll talk a little bit more about that in a moment. Then the next piece of this is to determine, how these things are managed, discovered, provisioned, and how they're secured in a unified fashion, so that everybody understands that what they're deploying, first off, is being deployed in a secure fashion. Secondly, whenever they look at these solutions, they understand a common set of commands that allow them to manage these in a ubiquitous fashion, as well as to discover and provision new solutions on top of these devices. So when we look at the sleds, what are we talking about? Really, as the title says, the slide, the possibilities are limitless. There's many things that can be offered up in this type of environment that can take and evolve essentially the capabilities, where some limitations may exist due to form factor and things of that nature. I mean, the PCIe card is a great example to where it's been one of the most deployed solutions in the marketplace today for extending and solutions beyond what their capabilities are. Whenever we look at these kind of things, they can only do so much because you can only fit so much. However, looking at the flexibility of this OpenEDGE solution, you have the capabilities to be able to have more form factor, more capability that's exposed on these solutions. So you could implement a full edge gateway on a card, for instance, because you could have CPU capability with networking directly attached, as well as storage is one possible example. Or you could do other things like implementing, just I/O expansion elements that allow you to take and integrate things like a PCIe card or an OCP mezzanine card to be able to expand the capabilities and put multiple aspects of these pieces together to be able to satisfy the edge gateway personalization, so to speak, or the edge appliance personalization. So when we look at this, what are some of the types of extensibility that could be brought on are types of servers. So we're going to talk through 3 or 4 of these and then talk a little bit about how these come together. This is one particular area, to where the compute sled may need some extensibility. You may need the ability to do, a double wide card, or you may want to look at additional drives, from a perspective of an ADS-FF form factor versus a standard 2.5-inch drive for an accessible form factor. These are the things that I think that need to be comprehended in a ubiquitous fashion from a specification standpoint to allow all these things to happen. Then the OEMs and the ODMs can bring their submissions forward to allow these solutions to be personalized, to allow value add. But still, when you look at this from a way a compute system's managed, it's still discovered the same way. It's still provisioned the same way. It's still, brought on board the same way. So looking at that kind of flexibility is key. So there will be compute sled, considerations in the space specification to determine how we allow that personalization, but at the same time, keep the aspects of the solution intact so that there's not huge software upheaval when you start to move from one type of chassis to the other. The second thing would be an expansion sled. So if you look at the solution that we're presenting here, it may be a situation to where you have a need for only the compute that's required from a 1RU solution. However, you may want to talk to an expansion sled that has some of that same peripheral expansion we talked about on the CPU card. You may want to have a high performance AI accelerator on there that could be a graphics card or FPGA, or specifically designed ASICs or silicon that allow this capability. You may want to have more storage. I'm showing the EDS-FF again. You may want to have the ability to be able to move to additional PCIe cards or OCP 3.0 mezzanine type solutions that allow these things to come together. However, when you look at some of these solutions, the implementation from a software perspective may be easier to be PCIe versus Ethernet. And in that situation, you have to consider that type of attach. And these are some of the things that we're looking at, of where you may want to have not just Ethernet attached over a PCIe coming off of a compute module. You may want to consider, and we're looking at what would be the right type of scenario that we want to bring up by 8 or a by 16 PCIe directly, because then the software just more seamlessly integrates. Storage sleds are a consideration as well. If you take that compute sled that we talked about a moment ago, and you pair this with the storage sled that's envisioned here, you end up with 12 highly capable drives in a 2RU half-width form factor with a lot of performance computing. So we're also looking at, should inter-chassis PCIe connectors and those connector concepts be envisioned as well to allow applications such as CDN to be envisioned in these future implementations. Also, networking has to be considered. I mentioned a moment ago about, there's certain work that's going on with switch sleds that certain vendors are doing, and they're bringing them forward in this type of a form factor. However, when we look at that, there's so much more from a switch perspective that we offer. This gives you so much more capability to where you could offload a full portion of the networking aspect, just plug in a sled, and then you essentially could have a firewall. You could have security isolation. You could have SD-WAN that's implemented on this solution in addition as a full plug-in card that plugs into this chassis that gives you network connectivity to potentially your entire rack, depending on how many switch ports and what you're implementing in the solution. So it allows you more expansiveness. It allows you more capabilities to have more sophistication on the sled itself than like you would see with a PCIe add-in card. And it allows you to be able to take some of those concepts where there's infrastructure acceleration with SmartNICs, but there's only so much, again, you can do because of the form factor limitations. This allows you to take and build a SmartNIC on steroids, essentially, and make not just a NIC, but a chassis-based appliance if we do this and implement this properly. Finally, how does it all come together? Well, in this particular implementation or example, we're showing how that all of these particular solutions can be brought together into a single chassis-based solution. If you look at this, this could be a box that's deployed on a wall, essentially in a box store somewhere, that allows you to be able to have the compute capabilities you need. It allows you to have the networking capabilities, allows you to have the storage capabilities, but it also allows you to have the flexibility and the versatility to exchange and adapt as the edge continues to adapt. As we said to start with, we already have a world-class OpenEDGE chassis implementation. Really and truly, it's an excellent solution when you look at other options that are available in the marketplace. However, you know, we need to take and evolve this to the next level of intelligent networking solutions, and, you know, allowing the ability to implement disaggregated solutions as well as hyper-converged solutions. It allows us to be able to have extensibility where we didn't have it before. And if we take our time and do this right, in a fashion that the industry can absorb and comprehend, then we will have a solution that is not only, you know, world-class from a physical implementation, but also world-class from a deployment standpoint. It allows us to be able to discover and orchestrate and manage and deploy new applications. It allows us to be able to understand telemetry and to implement that telemetry in a fashion that allows artificial intelligence. It allows you to be able to access, you know, easier to essentially the wireless networks that's coming along, such as the 5G solutions. It allows these things to be comprehended, implemented in a smaller form factor with the extensibility that, again, could be world-class. So with that said, you know, how can you help? How can you help define this? Well, as we look at solutions, we're looking to, you know, essentially evolve the OpenEDGE. And, you know, you can, first off, if you have questions or comments, you can give the people on the right-hand side email or contact us, or come join us at the Telco project as well as the OpenEDGE subgroup. So join those particular things. You can use the link on the right side, fourth bullet down, or directly to get access to the OpenEDGE subproject. The link and learn more about that, it's located at the bottom. In addition to that, we also have a link, the very bottom link, which is to the base specification that we're working on. You know, and with that said, what is left to do? What are we needing to finish with collaboration and implementation? Well, we're still needing to understand the sled types, as we talked about, and understand what those can be. In addition to that, more importantly, we need to define how these things all tie together. We need to understand the firmware requirements and the BIOS requirements. We need to get profiles for these types of things into the OCP. ONI is the path where we're looking down one path and into the, you know, some of the redfish profiles that's being driven through some of the OCP work as well, to understand how these things come together. We need to understand environmental requirements for these sleds and where the capabilities are. We need to understand how these things are going to manage, how these sleds are going to be defined, so it makes it easier to identify these sleds and what capabilities exist on these sleds. And then finally, we have to understand the interconnect technologies that exist within each of these particular implementations. So with that said, this is kind of your call to action. Please, I encourage you to come join the meetings that we have to provide your input and provide, you know, what you're seeing from a marketplace is going to make this easier to consume. This is open for service providers. This is open for, you know, OEMs, ODMs, software providers. It's open for anyone. So please come and join us. With that said, I believe we're going to have a short Q&A after that. I really appreciate the OCP for having me. I appreciate the time and consideration in this presentation. And again, feel free to contact us with any questions you have. Appreciate it. Thank you.